Hey, good morning. Welcome to another episode of Coding with MassTransit, or whatever we want to call it today. But season 3, episode 7, going to get kicked off. First, a couple housekeeping things just to kind of throw it in here. Get the right screen up, that would help. Um, Episode 6, if you haven't watched it yet, episode 6 introduced durable futures and kind of took all the work we've done with season 3 and kind of rolled that into a concept that I'm going to continue to explore in this episode. Hey, good morning, good morning, good morning. Afternoon if you're across the pond. It's all good. Um, so the durable futures that we introduced, if you haven't checked it out, the video is on YouTube. You can jump to the YouTube channel and catch that. A lot of iteration on this. I mean, I think that video was what, Thursday, and I've kind of thought about this a couple days. I was gonna try to produce this yesterday, but I found a really obscure reconnect bug, and I spent probably 18 hours of painstaking brain energy to try to fix that. Mainly reproducing it was the hard part, but fortunately, the submitter put a really awesome reproduction case, and through a bunch of Docker containers and HA proxy restart scripts, it was able to finally reproduce it and finally fix it. So that's a good thing. But yeah, that killed my brain Friday night. Way too crazy. But, goes on. And speaking of frying the brains, we're going to start frying onion rings today. See, episode 7, we're going to add a new menu item to the restaurant. We're going to have onion rings. Because when you think about Texas, you think of two things. Well, let's just think of one thing right now because the other thing isn't worth thinking about. You think of onion rings because, barbecue and onion rings. And what better than to put a barbecue burger with onion rings on the burger? I mean, that screams Texas. So what I want to do today is we're going to add a new menu item. Now you can get barbecue sauce and onion rings on your burger. And onion rings have to come from the fryer because you can't really cook onion rings on the grill. I mean, I guess you probably could. That'd be like grilled onions, but this isn't in and out. Um, but we're going to have to send a command to a fryer. So I'm going to have a new consumer. And I did this as a consumer because we don't really need a routing slip for the fryer. We're just going to throw the onion rings in a fryer for however many minutes and have them ready when you need them. And this is going to introduce one of the things that, when I look back and watch the episode, it was one of the things about task of T and when you think about futures in general is you can pass them around and other people can add, can wait on them and do things when they're completed. And onion rings take a while to cook. Usually it's like, I don't know, from frozen to delicious in what, 3 minutes? I mean, I have no idea. Those industrial strength fryers can pretty much turn anything into anything. But I wanted to be able to, as part of prepping the burger, if I'm going to grill the patty for 3 minutes, and I know onion rings take 3 minutes, I would like to get that onion ring at the same time and concurrently prepare that onion ring, even though it's needed to dress the burger. So the dress activity gets some new capabilities and being able to take that onion ring and put it on the burger, but it has to get it from the fry station. So a lot of interactions we're going to explore today. I think it's going to be pretty fun. We're also going to add Application Insights visibility because there's a lot going on in the log file, and while you can watch all the Saga interactions, being able to view the live telemetry on App Insights or any telemetry tool that supports diagnostic source listening is, I think you'll be blown away. I first brought it up because I forgot I had it running on Azure, and I actually found an old instance I left running that was still reporting SQL checks. So anyway, that's why my App Insights bill was a little high. And speaking of high bills, MassTransit, last night we got our first sponsor on GitHub sponsors. So if you haven't been to the GitHub sponsors page, I tweeted it this morning. It's sponsors Fatboy G. And within seconds, we got another sponsor. So that's awesome. Thank you for your support. It's really appreciated. It definitely is a strong validation of the work that I'm doing. And it's a support of open source. So that's really awesome. It's a new program GitHub had, and I set it up towards the end of last year just to see what it was about. And yeah, so far I'm pretty excited. 2 sponsors, and hey, it's great. So thank you for your support. Definitely appreciate it. So thank you. So now into the content here. So we want to have onion rings and we want to be able to fry onion rings. So like I said, I created this as a consumer. So if I go into my components, let's look at the consumer. And I didn't reset my font before starting the session. So let me fix that real quick. Okay. So the fry onion rings consumer is really complicated. It uses a fryer and it knows how to fry onion rings. It's pretty difficult. It gets a quantity, how many onion rings you need, because you can only fit one on the burger, but you know, if the customer wants more, I'm sure we would make more. And this is a simple request response consumer, because if you remember with durable futures, we're trying to just stick to the basics. And this is a service. You know, it's using the fryer, which is a service, much like the grill. And so we're just going to fry the onion rings, which however long that takes, you know, if we go look at that, it takes a second to fry onion rings. That's awesome. And then we're going to respond that the onion rings were fried. So it's really a super simple request response consumer. You know, it's no different than if I were to take a command and publish onion rings fried and have something observe it through a pub sub framework. The reality is I don't think most people really care about the onion rings being fried other than the person that asked for them. And that's why this whole durable future concept is coming to be, is when you get a system where everything is published and everything is subscribed, it's great for additive type things, but some things you just really don't need to know about. Or if you do, it's by word of mouth, or in this case, by reference, because it is a language. And so we're continuing to stick with this as we explore this. I could have just as well published an event and hoped that it came out. I think I actually use a request client for this. So if I look at, no, I don't actually. Okay, so good. So I just respond, great, awesome. The way respond async works is if there isn't a response address in the command, it publishes the event anyway. So you're getting kind of dual purpose. If there's a response address, it sends it right back to the originator. If there isn't one, it just calls publish. So you don't have to do both because it's already kind of done for you. You know, it's just with the response address, it's narrowcast sent to that response endpoint. Otherwise, it's published. So good to know there. That's our simple onion ring consumer. This is way simpler than the routing slip for the burger because the burger has multiple parts. It has a cold side and a hot side, which if you remember McDonald's in the 80s, they had the McDLT, which actually came in two giant styrofoam halves with the cold side cold and the hot side hot. And I think they were criticized for wasting even more styrofoam and destroying the environment. But anyway, they don't sell that anymore. So it's all about the, quarter pounder now. So going on with this, we know now that, excuse me, we need to update our burger contract on our menu so that we can ask for more things. The first one being barbecue sauce, because, you know, we want barbecue sauce. And we want to be able to ask for an onion ring on our burger because why not? Fried onion rings on a fried burger? Great, awesome. And we've updated just the output so that we can see that on the receipt slip. But how am I going to use this information? So as I've enriched my menu, I have to enrich my components to support that too. So if we go to the itinerary planner for the burger, the only change we've had to make here is we've had to add barbecue sauce and onion ring to the dress burger activity arguments. So if we go to the dress burger activity and look at the arguments, we've taken and add those two properties in there saying, hey, you can now add barbecue sauce and an onion ring to a burger. Which, you know, I'm sure there's a standard operating procedure manual that they give the dress staff so that they know how to dress a burger. And the other piece of that with the planner is that's called by the activity within the state machine for prepare burger activity. And this is where an additional piece of functionality has been added. So if we were to just tell the dress activity, and let's go to the dress activity. Sorry, I'm jumping around so much. I kind of wanted to show this here. The dress burger activity now takes those arguments, checks to make sure the inputs, and then says, hey, do I need an onion ring? Because if I need an onion ring, I need to order it. And it's going to order that onion ring and using a request response. It's going to take the order ID, the order line ID, which is the burger ID, and a quantity of 1 and order that onion ring. Because again, it doesn't know where it's coming from. It just knows that it has a request client to get an onion ring. And the command it's going to send is order onion ring, I think. Right, just like we have order burger and just like we have submit order. Order onion ring is very simple. Order line ID and quantity. The request client is just going to do an immediate request response because it can't do anything until it has the onion ring. It's not really awaiting anything here. It's going to send that, and if the request is faulted, it will fail. And I mean, I'm just using basic invalid operation exceptions because I don't want to create a whole exception hierarchy, but you probably would in a real app, and so I'll probably get to that eventually. But I only care if it's faulted, because if it was okay, I know I have the onion ring now and it's in my hand or whatever. So then I can prepare the burger with the onion ring and all of that. Now, if we remember right, it takes a second to make an onion ring. And because we know the onion ring is there, it would be nice if I could send a command, not with a response, but just a command to get that onion ring being made, so that so when the order comes in at the grill, it's like, they can look at the order. When the order comes in, the onion ring station comes up and it says, hey, drop onion rings. I need one for this burger. So what I did is, within the prepare burger activity, after I plan the itinerary, I'm checking, and I'm checking right here. I think it would probably become part of something like the itinerary planner. I haven't quite teased that out yet. But if they're asking for an onion ring, I am just going to publish. I don't care about the response. I'm just going to publish a command, order onion rings. I'm going to give it the order ID. It's for the burger that I'm making, so I'm going to use the same line ID as the burger ID, and I'm going to ask for a quantity of 1. So I'm saying, hey, I need an onion ring for this. And because I'm publishing it, I don't care about the response. This is just a command being sent. It's fire and forget. I'm going to create this future with these identifiers for this onion ring for this order, so that when that gets to the dress station, chances are the onion ring might already be done if it was able to get to that and process that command and complete that future for the order onion ring. So that's the interaction that we're looking for here. And of course, I had to create a new state machine because I have the onion ring state, which is the order ID, the quantity, and the exception info, which is basically what's in all of the other states. And I have the state machine, which is right here. The state machine has the requested, the 3 events, order onion rings, the response from the consumer, because if you'll remember in the burger state machine, let's see if I can split this out here. In the burger state machine, we looked at these 3 events, order burger, and then because it was a routing slip, we had routing slip completed and routing slip faulted. In the case of onion rings, we're using a consumer instead of a routing slip. So we're looking for either order onion rings is the command, and then the response from that consumer is onion rings fried, because we told it to fry onion rings, or fault of fry onion rings. So if there is a fault returned from that consumer, then we will know that that faulted. So same interaction of completed faulted with the consumer, but different events because we're using a command instead of executing a routing slip. And then I have the output of this is the same as the others, onion rings completed or onion rings faulted. I'm feeling a lot of duplication here, like eventually we're going to be able to come up with a nice clean, future base state machine that we're able to pull in. So hold on, let's see, we got a comment here. So the activity of verifying the order is complete and correct prior to giving the customer food is what the routing slips helps with. So not in this case. So the routing slips for the burger are the actual creation of the burger. The order is the actual order state machine that's tracking all of the different lines within that order. And so that's within the order state machine where that's tracked. The burger state machine is keeping track of the routing slip for the burger, which includes a grill activity and a dress activity. In the case of onion rings, we're just frying the onion rings and they're ready. So there isn't we don't have to dress onion rings. We don't have to put sprinkles or something on them. It's just not, donuts with sprinkles would actually be good right now, but not onion rings with sprinkles. That wouldn't be a thing. So the onion ring state machine, I literally cut and pasted burger state machine. And like I said, I feel like we're getting to the point where we're going to be able to have a MassTransit future base where you specify 3 types and a couple of methods to create the messages. And we should be able to pretty easily create a way to develop futures without a lot of repetitive code. And we'll do that in this example because, again, we're trying to figure out how everything comes together. Yeah, so each burger gets its own routing slip, and we'll see that here shortly when I bring up App Insights. You'll see them all run. Okay, so all of this is in here just to support the onion rings. We've updated the dress activity so that they know how to get the onion ring. We've updated the itinerary builder for the burger state machine to basically pre-fire or execute the command, send the command to say, hey, I'm going to need this onion ring for this order, so you might as well go ahead and start making it. And that gets that future already started. So subsequently, when the address activity asks for it, it's potentially already done. And if it isn't done, it'll get a response when it's eventually done. Again, it isn't a matter of having timeouts and things like that because we know it's going to be done. It's either going to succeed or fail. So doing a bunch of scheduling of timeouts isn't necessary. Looking at my notes here. So with the command sent, we don't need, when we publish the command from the prepare burger activity, we don't care about the response. We don't need a response address because we're just publishing that command. There's no need for it to respond. And it still completes. And once it's completed, if we ask for it after it's already completed, we'll see in that messaging interaction that it's already done. Okay, so now we're going to actually run it, and let's see what it looks like. So we're going to go back to running the code, because it's time to run the code. We already have the Docker containers for RabbitMQ and SQL Server running, so it'll just come up and bring up our endpoints. Still starting that up. If we go and look at RabbitMQ, you can see we have a new fry onion rings consumer queue for the consumer. We have the onion rings state, which is a new state machine queue that we have. And those are the only two additions with the onion rings being added. So now when I go to Postman, and I've updated this request to see it, I've only had 2 burgers this time. I'm only going to create 2 burgers, but you can see right here, there's my barbecue sauce and there's my onion ring. So I'm going to get some additional stuff in this. So I'm going to go ahead and send this request. We're going to wait for that response. And there's the response. We've got 2 lines completed. One is a burger, 1 pound, pickle, onion, ketchup, mustard. And the other one is a burger, ½ pound, cheese, pickle, onion, ketchup, mustard, barbecue sauce, and onion ring. So that is literally like the super burger. I mean, not for me, but hey, somebody's going to eat it. And if we, so that's the interaction. If we go look at the logs on this, you'll see, I mean, it's hard to see in the logs. I think it's probably better to show it in a telemetry tool like Application Insights. So I'm going to pick the one I did last night because it takes a few minutes for the information to get all the way up there. And I'm going to back up because it wasn't that one. This is weird to close. So that was that one. I'm going to get the one that was right before that, maybe. Let's see here. This one. Okay. So it's a lot to see in here, and I don't even know how to move this. This is weird. It doesn't give you a whole lot of control over the trim. But you can see in here, and I don't know how to make it bigger because I think that's kind of tiny. Let's see here. Make it bigger, and then you can see even less. That's awesome. Yeah, that's great. So we're going to shrink it back down. Sorry. It's the reality of the world that we're in. Now it's all screwed up. This sliding thing on the Azure portal is really weird to me. But we can see here's the initial HTTP post that went to my service. Hit the chevron on the right. This one? Okay, that's a little better. Oh, and that one. Okay, but then how do I slide this? This is what I want to really slide. I want to see the longer names. That's the one I want to see. Welcome to the new experience. Yeah, whatever. All right, so this is the entire telemetry of a request to create the burger. You can see the post via HTTP, the initial submit order message that was sent to the queue, the order state queue receiving it, Saga repository loading the Saga, and you can actually come in here and see all the different correlation IDs. I think I have to show all, and you can see the operation IDs, dependency IDs, all of the span Sagas. We can see the Saga being loaded. And you can go down to Saga ID, there's the ID. You can see which state it started at, initial, which state it ended at, waiting for completion, which is how our futures work. You can see the event that was raised, the order state Saga message type, or order state is the Saga type. The message is the submit order message. You can see where it sent the order burger to the burger state machine. How the burger state came out. Can you get telemetry with Serolog? Serolog doesn't have telemetry, so no. You can get logging with Serolog, which we get, but you need to have some sort of telemetry. And I believe they're working on an open telemetry adapter for MassTransit, but there's some changes with the way things have worked with span IDs and connection. Anyway, there's a thread for open telemetry that has it, but yeah, not with Serolog. Serolog is just logging. But you can see here, the burger state comes up, it goes to prepare the burger. The first thing it does is it sends that order onion rings command to that endpoint, which is a publish. The order ring state actually receives that, loads the repository, creates the future, and then it sends the fry onion rings to the fryer, which receives the fry onion rings. And I mean, it goes all the way down. You can see all the way to where the onion rings get completed, to where it sends the request to complete any other futures that have been cached on there. All of that is happening while concurrently we're grilling the burger. Burger is grilled, the burger is dressed. You can see the whole chain all the way down. The burger state gets told that that routing slip is completed. It gets handled by that. The order state, the order line completed goes back up to the order, which then completes the order. And then eventually we actually complete the whole order and complete the request back to Postman. So all of that sort of comes down. The visibility on this is awesome. You can see it took however long to grill the burger, whatever my rule was on that. I think it depends on this must have been the full pounder because it took 6 seconds instead of, the 5 seconds of the other burger that we cooked. So it was a smaller burger, yeah. Yeah, but you get to see all the way down how it creates it. And I mean, that visibility and that telemetry information is super useful to visualize, more so than just looking through a linear log file and trying to correlate it yourself. So, I think this helps me a lot. It gives me a good visualization, so I think that's pretty cool. If we go back, I think I do this one, and if we refresh, let's look at the last 30 minutes. I should have the one that I just did. That doesn't look like it has everything yet. Oh, wait a minute, hold on. This came back super quick because I didn't take the GUIDs out, my bad. That was actually just checking the status of the previous order. So we're going to order it again, and this time we will actually submit an order. And it will actually go to, and if we look at the logging here, you'll see it actually doing all the logs, and you'll see the burgers are being prepared, the onion rings got cooked, the burgers are getting completed. So this is your serial log output, as far as being able to see that. You'll see all these run. I'll go back here, and now I have the result for that with my new burger. So that will take a second to show up in Apps Insights. What's interesting is the request that I made today, which because it still had the GUIDs of the same order again, remember these are durable futures. That had already completed, so the call chain is much smaller because all I did was say, submit order. The order state said, yeah, if you look at my initial state in the saga right here, I've already completed. I'm in that completed state already. So my end state, I'm going to stay completed. And the only thing I did was reply back and say, yeah, we're good. The message I just sent you, which I believe is order completed. Yep, there's the message type, order completed, which is a future completed. That sends back, completes the request handler and the controller, which if we remember our order controller, all it's doing is using that order completed, order faulted, submit order. You submit the same order with the same identifiers, you're going to get the same thing back. And you can see I'm doing a response switch here to say, hey, depending upon the type, it was either okay or a bad request, and I return what was either successful or failed. So the new response type, the new get response pattern matching is actually pretty handy. I mean, it cleans up much better than the multiple tuple response from before, so good. Yeah. All right. So that's where we're at. I think the visibility on this is super cool. We added onion rings. We added the concept of being able to just send a command to start a future, and then using that same command to get the completed future and use it downstream. So let's see here. So that means the operation is idempotent. Correct. I could submit this order 100 different times with the same GUID, and it will never create the order twice because the future has already completed. And that's the whole concept of this is being able to, and it's a composability thing. First, being able to submit the same order and know that it's already completed and not doing it again. There's your idempotency. That's like one of the things is like, well, how do I make it idempotent? Here is the answer that I'm thinking of. And it's this durable future concept. And as we've seen with both the burger state machine, the onion ring state machine, and the order state machine above it, we can compose these as deep as we want within the system. So after doing episode 6, and kind of looking around, I mean, originally this was this was thoughts I was having towards the end of last year. And I started looking on YouTube for other videos of people doing things. I just did keyword searches for like orchestration and choreography. And I found a number of people using different tools. I found one that I found the other day. Yeah, memoization is a big part of it. It's the concept of that. And I looked at how other people are doing it. And there was one video I saw, I'm trying to remember what it was, Code Opinion or something, and they were using in-service bus. But they were basically putting sagas at different points depending upon whether they wanted to call it orchestration or choreography. And again, as I said earlier in the series, orchestration is more like taskmaster type stuff. You have a central point of control that's telling things to do things and then coming back and then telling them to come back. And choreography is really this dance, thus the choreography, around commands and events and combining them together into useful components. And as I watched it, I mean, it resonated more that this durable future mentality and staying within a mental model that people understand. And it even, again, as we broke down in the initial episode, request response is really, in messaging, is just two message exchanges. A message sent to a queue that's read by a consumer with another message sent to a queue that's read by a consumer. So when you think about it that way, and you can use that exchange a number of different ways, because when you think about it, if you have a command, you know, and there's this whole thing of, oh, well, I should be using commands and events, it's CQRS and whatever. If you have a command and you can't do anything else, or you could do other things, but at some point that result or the event from produced by that command is needed to continue, I'm sorry, that's request response. You know, break it down. You're doing something, and in response to something else, you're doing something else. And you know, we moved away from continuation passing with async and await. And my feeling in how this model is working out with durable futures is we're going to have that same type of experience of async and await once we kind of tease out some more of the principles and be able to do that with messaging to say, hey, I'm awaiting on this, and once I get that, I'm going to do this, and once I get that, I'm going to do this. And you know what? If I don't get it back within a time that I'm checking it, if submit order times out, the order is still submitted. I can submit the same order again and check it. So I can reevaluate all of the futures until they're all complete. And then once they're complete, I can do something else. And if you think about that from like a work or a background or a task scheduling perspective, or just a work queue perspective, being able to just rerun the same high-level command of submit order until it succeeds or fails is kind of huge. I mean, it reduces pressure on scheduling and scheduling timeouts for events and dealing with all of that. You can still use timeouts to say, hey, I've been trying to complete this order for the last 10 minutes. The customer just walked out the door. We need to do something better because we've just lost a customer because we missed a window. We can still observe events and say, okay, well, this order was submitted at noon. It's now 12:05. Let's get a rush on this. Maybe we do some things to reorder some queues or prioritize some messages. Those are all things that we can build as our system grows. But the exchange pattern of completing a future and just being able to go down a list, and again, the message exchanges are completed. It isn't like I said submit order, and the submit order has to go out and ask each burger, or try to create the burger again, and the burger have to complete. We're able to use compositional tools like the order state machine, in this case, the order future, that has dependencies on other futures. And as they complete, it keeps track of that. So that's where the memoization comes in. We're remembering the results so that we can provide a composite result based on that output. So as we go down some of the further episodes, we're going to look at how we can compose these a little more and how we can kind of clean these up and get it to where we're reusing them within our enterprise use or our production use of MassTransit for these capabilities going forward. And again, as I said at the start of the series, I'm doing this as a user of MassTransit. I'm not saying, oh, this is cool, I'm going to go modify MassTransit to support this demo. That isn't what I'm trying to do. I'm trying to consume MassTransit as a tool to build these type of systems. And I'm doing so in a very realistic way. So one of the comments that a friend of mine who I invited to the episode Thursday said is, he said, this code feels very clean. It's like it's almost academic in that it doesn't look like any of my production systems. And so I was like, okay, that's good feedback to know. I mean, what type of things do you see in production systems? Like, oh, well, there's workarounds and this and the other. And as we kind of dug into that, it was like, and why is that workaround in place? And And any code base is going to have, solutions and, Friday night hot fixes that fix production. And I think there's a realistic expectation that is going to happen. Better system design can definitely reduce the impact of those and how many different systems you have to change when they happen. But if you can think of any like crazy cases, and I have we've brought up the idea of substitution of what if there isn't lettuce? Can we just go ahead and make the burger? And that's the real world solution, is that they're just going to make it without lettuce and say, I hope you like it. They aren't going to fault the burger. But you can't do that if you're out of stock on an item. You have to back order and things like that. And so, the food restaurant is really just a supply chain metaphor that's easy to understand. So I still have some content coming up in future episodes, so definitely keep an eye out. Anyway, I think this is cool stuff. I will get this code up on GitHub without my telemetry key for App Insights this time, because last sample I put my telemetry key out there and I started seeing all sorts of weird stuff on my App Insights. So I'll try not to share that key this time, so I don't have to delete my App Insights namespace and recreate it again. But let me know what you think. Twitter, Discord, all the different places are linked in the YouTube description. Catch the channel on YouTube, subscribe if you haven't. And thanks for tuning in. The support is great, the feedback is great, and it's been a lot of fun building this sample. So I'm looking forward to kind of fleshing it out and seeing how durable futures become a key idiom in building distributed applications. So thanks for joining. Have a good day, and we'll catch you on the next episode.